Hello everyone, today we'll be solving this integral. So the first thing I'm going to do here is take the u substitution of arctan x, and then when we differentiate this with respect to x, we can get 1 by 1 plus x squared, and when we rearrange in order to make dx the subject, we can write this as du into 1 plus x squared to give the x. And now when we put this back into the integral, we get e to the power u upon 1 plus x squared, 3 by 2 into du 1 plus x squared, and when we cancel this 3 by 2 in one power, we get e to the power u upon the root of 1 plus x squared du. But you notice we still have the 1 plus x squared in the denominator, right? So we want to make that in terms of u. So we can go back to our u substitution of u equals arctan x and write that as tan u equals x. And then we can recall the identity, which says sec square u minus tan square u equals 1. So tan square u, 1 plus tan square u equals sec square u. So if we go back into the integral, we can write that as the e to the power u upon the root of 1 plus tan square u du, which equals the integral of 1 e to u by sec square u du, which can further be written as e to the power u upon sec u du, which we can finally rewrite as e to the power u cos u du. Now, as you notice, we're still not done. So we have to continue by doing integration by parts. So we use the Lyot rule, and hence we know the thing that we differentiate would be cos u, u dash would be minus sine u, b dash as e to the u, b would be e to the u. So if we take I as the integral e to the u cos u du, cos u, so this would end up being I equals e to the u cos u plus the integral of e to the u sine u du. Now, next thing we have to do is go and integrate this by parts again. So we had u equals sine u dash equals cos u, v dash equals e to the u, and v equals e to the u again. So now, as we're going with integration by parts again, we do the same thing. So I equals e to the u cos u plus e to the u sine u, and then minus the integral of e to the u cos u du. As you notice, we already have I equals e to the u cos u du over here. So we can write this, if we take this to that side, we get 2I equals e to the u cos u plus sine u, and then I equals e to the u cos u plus sine u by 2, and also add your plus c's, because we're not Republicans. Now, as you notice, u was arctan x, so we need to plug that back in before we finish up our answer. So e to the arctan x cos arctan x plus sine arctan x upon 2 plus c. And that's our final answer. Thank you for watching.